Hello and welcome everyone. I am here Javish Bhattacharya with you in Civil Engineering Study and Construction channel. Today in this video, we will continue our discussion on lateral earth pressure with part 2 of this topic. In part 1 video of this series, I have discussed different type of earth pressure and stated in details different types of earth pressure like active earth pressure, passive earth pressure and pressure at rest. The details are given in the description box of that part 1 video. I request you all to please watch first the part 1 video and then this video. This will help you to understand the topic clearly. Friends, in the design of retaining wall, one of the most fundamental and widely used concept is Rankin's earth pressure theory. To truly understand this theory, we must clearly understand the assumptions on which it is based. Today, in this video, I will explain Rankin's earth pressure theory and more importantly, I will discuss in detail the meaning and engineering significance of each assumptions such as semi-infinite soil mass, homogeneous soil, cohesionless soil, dry backfill and smooth wall surface and wall yielding. So let us start step by step by Rankin's earth pressure theory and its fundamental assumptions. First of all, I will state the assumptions of Rankin's earth pressure theory. There are 4 assumptions. One by one, I will explain later in pen and paper. So friends, these are the assumptions of Rankin's earth pressure theory. Number 1 assumption is the soil mass is semi-infinite, homogeneous, dry and cohesionless. Number 2, the ground surface is a plane which may be horizontal or inclined. Number 3, the back of the wall is vertical and smooth. In other words, there are no shearing stresses between the wall and the soil, and the stress relationship for any element adjacent to the wall is the same as for any other element far away from the wall. And number 4 assumption is the wall yields about the base and thus satisfied the deformation condition for plastic equilibrium. Now I will explain each assumptions in detail. In the number 1 assumption, there is one point that soil mass is semi-infinite. So what is meant by semi-infinite soil mass? Say this is a wall which is retaining the soil mass in this side. This is the field of soil level. So the word semi-infinite means the soil mass extends infinity in horizontal direction. This is horizontal direction. This is horizontal direction. The soil mass will be infinity and downward direction. This is downward direction. So in downward direction and in horizontal direction, there is no limitation of this soil mass. But it has one free surface and that is the ground surface. So here it is limited. So it is not bounded by any vertical or horizontal rigid boundary. It means there is no horizontal or vertical rigid boundary which is restricted the soil mass. It extends very far away from the wall. This wall extends very far away from the wall and the only boundary is top ground surface which is open to air. Just imagine you construct a retaining wall. Behind the wall, the soil continues very far. It means this is continues very far. So far that its end does not affect the pressure on the wall. That condition is called semi-infinite soil mass. So it is infinite in some directions, infinite in some direction, not all. Therefore semi-infinite. It is infinite in this direction and in this direction, but limitation is there in this direction. So why this assumption is made? Rankin assumed semi-infinite soil mass to avoid boundary effects, simply mathematical analysis
ensure uniform stress condition, consider failure wedge formation without restriction. We know this is the failure wedge. In earlier video I have stated this. This portion is called failure wedge. If soil had a boundary nearby like rock or another wall, here the earth pressure would change. That's why Rankin considers the semi-infinite soil mass. In number 1 assumptions, there is another point, that is homogeneous soil mass. What is homogeneous soil? Homogeneous soil mass is a soil mass in which the physical properties and engineering properties are the same at every point throughout the soil. It means what the value is here is equal to here, 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 and everywhere is equal.
It means that the density is same angle of internal friction, same cohesion and same permeability, and same strength parameter everywhere in the soil mass. Properties remain uniform. In simple words, if you take some soil sample from near the wall or 2 meter away or 10 meter deep, 1 meter below the surface, all samples will have identical properties. That soil is called homogeneous soil. Now question is this, that why Rankin assumes the soil as homogeneous? He assumed it to simplify the analysis. Earth pressure varies uniformly with the depth. Failure plane becomes predictable. Mathematical equations become simple. Active and passive pressure formulas become valid. And what are the effects in earth pressure formula? Because soil is homogeneous, unit weight is constant, angle of internal friction is also constant. So active pressure formula remains valid throughout the depth. If soil were non-homogeneous, then the unit weight and angle of friction changes with depth and calculation becomes complex. Due to the soil homogeneous, the lateral earth pressure increases linearly with the depth. Pressure diagram is a triangle because unit weight is constant. Now another point is the soil is dry. What does Rankin mean? The assumption that soil is dry in Rankin's theory means that the soil pores contain no water. Hence pore water pressure is zero and the lateral earth pressure is caused only by the weight and shear strength of the soil. Why this assumption is made? Because water changes earth pressure significantly. If soil is wet, pore water pressures develop, effective stress reduces, additional hydrostatic pressure acts on the wall. This makes calculation complex. So Rankin simplified by assuming dry soil. And what happens if soil is not dry? If soil becomes saturated, total pressure on the wall is the summation of earth pressure due to soil and hydrostatic water pressure. This increases total lateral pressure drastically. Thus, to keep the soil condition approximately dry and reduce pressure, drainage must be provided behind the wall by providing weefholes, drainage layer or filter media. Now another point in the assumption is soil is cohesionless. Cohesionless soil is a type of soil in which the shear strength is entirely due to the internal friction and the cohesion component is zero. Cohesion is the force that binds the soil particles together even without external pressure. In simple words, soil particles do not stick together. There is no bonding force between the soil particles. Shear strength comes only from the internal friction of soil particles. Now going to the third assumption of Rankin's earth pressure theory. This assumption says that the back of the wall is vertical and smooth. No shear stress between the wall and soil. The assumption that the back of the wall is smooth means that no frictional stresses or shear stresses develop between the soil and the wall surface, and the earth pressure acts normal to the wall. It means soil can slide freely along the wall surface. No friction develops between the soil and the wall. Only normal pressure acts on the wall. As the wall friction angle is zero, only lateral earth pressure acts perpendicular to the wall and no triangular forces exist here. Force reaction becomes simple because shear stress is zero. The fourth assumption says the wall yields about the base and thus satisfies the deformation condition for plastic equilibrium. The wall yields about the base. What does it mean? When a retaining wall rotates slightly outward above its base due to the lateral earth pressure, it is said to be yield about the base, resulting in the development of active earth pressure. Yield means the wall moves slightly due to the soil pressure. It does not mean collapse. It means small displacement of the wall. Yields about the base means the retaining wall rotates slightly about the base. The base acts like a hinge point and the top of the wall moves outward. Imagine a cantilever retaining wall. When soil pushes the wall, the bottom remains almost fixed, the top moves outward, the wall rotates slightly. Why this yielding is so important? Because active earth pressure develops only when wall yields. If the wall does not move, active pressure will not fully develop. Soil remains in at-rest condition and the pressure will be drastically increased. When wall yields outward, lateral pressure decreased. Soil expands slightly, shear failure surface forms, active condition develops, failure plane forms at angle. So friends, in this video we have thoroughly understood Rankin's earth pressure theory and the detailed explanation of all the basic assumptions, why they are taken, what they physically mean and how they influence earth pressure on retaining wall. These concepts form the foundation of understanding active and passive earth pressure, retaining wall design and many important problems in soil mechanics. If you found this useful and conceptually clear, do like, share and subscribe to the channel for more detailed civil engineering lecture. In the next video, we will move forward to numerical applications of different earth retaining conditions and different wall conditions. Thank you for watching and keep learning with clear concepts. Thanks again.